Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Pinwheeling by Webb the Third. And here are the rules. Aside from this is pinwheeling everywhere, we have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Digits on an arrow must sum to the digit in the attached bulb. So, for example, if this were, say, 3 and 5, this would have to be an 8 here, because the digits along this arrow are 3 and 5, and they add up to 8, which must be the digit in the attached circle. So that's an example of how arrows work. We also have digits on a pink line form a non-repeating contiguous set in any order. So we have no repeats on this pink line, and it's all just considered one pink line here. So basically, all of these digits are on this pink line. There are no repeats, and it must form a contiguous set. I'll leave that to more solving later. We have digits separated by a white dot are consecutive. So, for example, if this were, say, a 6, this would have to be 5 or 7 here to make sure that these digits are consecutive, because there's a white dot between them. And if we had a 4 here, this would have to, or actually, let's make this a 2. If we have a 2 here, this would have to be 1 or 4 to make sure that these digits are in a 1 to 2 ratio, because digits separated by a black dot are in a 1 to 2 ratio. And those are all the rules. If you'd like to play along, it's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, on this Renban, we have 9 cells, and since there are no repeats and they must form a contiguous set, it has to be the digits 1 through 9 once each. We also have, in the central box, 4 cells, which are the sum of 3 unique digits. So, the only possible combinations then would have to be 1, 2, and 3 at minimum, adding up to 6 at minimum. So these digits in these circles must be 6 through 9, which means the remaining digits in the central box have to be 1 through 5. So these have to be, let's make it low and 5, and these have to be high digits, which means the remaining digits on this Renban have to be the high digits, 6 through 9, because we already have 1 through 5 guaranteed in the central box. Okay. This digit is in a 1 to 2 ratio with this digit. Okay, so what digits can be next to a black crop key dot? You cannot have specifically 5, 7, and 9 next to a black crop key dot, because if it's next to the 5, 7, and 9 have to be basically, if you have them, you get 2.5, 3.5, 4.5. If you double them, you get 10, 14, or 18. None of which are digits, which is why they can't be next to a black crop key dot, because you would have to be in a 1 to 2 ratio with another digit. So this can never be 5, and these are high. This is a high digit, which is consecutive with another digit. Well, it's either consecutive with another high digit, or it has to be consecutive with 5. So because a low digit, I'm counting the low digits as 1 through 4, and the high digits as 6 through 9. Obviously, 6 through 9 cannot be consecutive with any of the digits 1 through 4, and only 6 can be consecutive with 5. So this has to be 6 here, which makes this a 5 here, which eliminates 5 in the rest of this box. So this is 5. 6 is in a 1 to 2 ratio. When it's added up with 3 unique digits, it must be 1, 2, and 3 adding up to that 6. We also know 5, 7, and 9 cannot be the digit that's in a 1 to 2 ratio with another digit. So it has to be 8 here as the other high digit, which makes this a 7-9 pair remaining in the central box. 8 is in a 1 to 2 ratio with only 4, so this is 4, which leaves the remaining digits in the central box as 1, 2, and 3. In this lower central box, these two digits must sum up to this digit here. And the minimum here is 4 and 5 because of the 1, 2, 3 triplet in the box. And 4 and 5 at minimum adds up to 9, which means we can't have any other digits here besides the minimum, because if we add something to it, so say we tried 4 and 6, that's not going to add up to a single digit. It adds up to a 2-digit number, which can't be the case in normal Sudoku. So this must be 4, 5 as a pair. This can't be 4 because of 4 in the column, so this must be 4 here, which makes this 5 there, and this adds up to 9 there. Let's see, what else do we have? To add up to 8, it's going to have to be 1, 2, 5 or 1, 3, 4. This can't be 4 or 5 here. This can't be 4 here, and this can't be 5 here. So if it's 1, 2, 5, this becomes a 1, 2 pair, and this would be 5. So this could not be 2 there. If it's 1, 3, 4, these would have to be a 1, 3 pair here, and this would be 4, so this can't be 3 then. Remaining digits of this lower central box are 6 through 9. Oops. I don't know what happened there. 6 through 9, and this cannot be 6 or 8 because of the 6 and 8 in the column. This can't be 9 because of 9 in the row, so this is 7. That eliminates 7 in the rest of this box. 5 is consecutive with either 4 or 6 here. This digit is a high digit. These digits are all high digits. We have lows here. And this must be a high as a 7. We have 1, 2, 3 triplets in column 4, which eliminates 1, 2, 3 in the rest of the column. So these cannot be 1, 2, or 3. We can't have 4 here. We can't have 5 here. Therefore, these are both high digits. This is 6 or 8, which is in a 1 to 2 ratio with 3 or 4 only. What else do we have here? So, what can these add up to for 7 or 9? If it's 7, it has to be 1, 2, and 1, 2 with 4. If it's 9, it could be 1, 5 and 1, 5 with 3. Or 2, 3, 4 as some combination. This can't be 4 because of 4 in the row. These could be quite a bit. But this digit is... So these digits have to be 6, 7, or 8 remaining. Because of the Renban. And we know that this digit can only be 1 through 6 to add up to 9 at most. And the digits that are consecutive with this, then, are 5 or 6 here. Because 1 through 6 is only available on this arrow to add up to 9 at most. And, because this is 5 or 6, because this has to be consecutive with this. You can't have any digits adding up to 7 with a 5 or a 6, so this must be 9, right? 5 at minimum plus 1 and 2 already adds up to 8, so that's not possible for that to be 7. So this is 9, this is 7, therefore this must be 4, with this being a 1, 2 pair here. And this is adding up to 9 with 5 or 6. This can't be 8 anymore then. 4 is in a 1 to 2 ratio with 8. So this is 8 here. That eliminates 8 on the rest of the Renban. So one of these is 6. We have to have 1, 2, or 1, 3, 6 adding up to 9. So therefore, one of these is 1. One of these is 6, which means this can't be 6, because it's either 5, 6 here, or 6, 7 here. Therefore, this can't be 6, it's 4. This adds up to 8 without 1 or 2 available because of the 1, 2 pair in the box. So this has to be 3 and 5 as a pair. This can't be 5 because of 5 in the row, so that's 3, which makes this 5. That eliminates 3 in the rest of this row, so we have a 1, 2 pair here. Which means the remaining digits are all high, because we have 1 through 6 here. And this must be 7 through 9, 7 through 9. We have to have a 1 here. So this is at minimum. Can it ever add up to 6? If we have 2 and 4, that would mean this is at minimum 1, 3, 5, which doesn't add up to 8. It adds up to 9, which is too big. So we cannot have a 6 here. We have to have a 7 here. So this is either 2, 5, or it's 3, 4 here, adding up to 7. This can't be 5 because of 5 in the column, so therefore this can't be 2. This can't be 4 because of 4 in the column, so this can't be 3. We have a 1, 2, 3, 4, 5 quintuplets in this upper central box, which means 1, 2, 3, 4, 5 cannot be in the rest of the box, so the rest has to be high digits, and this is a high. 7 eliminates 7 here, so that's 6, which means this can't be 6, that's 5. So this must be 1, 3, and 5 to add up to 9 here. So we have 1 here, 3, and 5. This must be 2, 4 as a pair. This can't be 4 because of 4 in the row, so that's 2, which makes that 4. 9 has to be here because that's the only high digit remaining in column 5. 9 eliminates 9 there. The rest of these digits in this right central box are all high because we have 1, 2, 3, 4, 5 accounted for. This can't be 3 because of 3 in the row. This 2 eliminates 2 here, so that's 1, which makes that 2. No 1 or 2 here, it's 3. 1 eliminates 1 here, so that's 2, which makes this 1. Therefore, there's no more 1 here. This becomes a 3, 5 pair. That limits 3, 5 in the rest of the box. So no 3 here. 2 here eliminates 2 here, so this is 1, which means this can't be 1 or 2. It's 3. No 1 here because of 1 already accounted for in the box. These are high digits again. This high digit cannot be 7, 8, or 9, so it must be 6, which leaves this as an 8. That eliminates 8 in the rest of the box, so this can't be 8. This is 7, 9 as a pair. That eliminates 7, 9 in the rest of the box, so this is 6. That forces this to be 7 or 9. The 7, 9 pair eliminates 7, 9 in the rest of the row, so no 7, 9 here, it's 8. Okay. Remaining digits here are 6 and 8, and we have 6, 7, or 8 there. 2 and 4 can be in a 1 to 2 ratio with 1, 2, 4, or 8, but you can't have 1 or 8 here because of 1 or 8 in the column. So this is 2, 4 as a pair then. Interesting. So to add up to 9, it has to be 5 here. To add up to 7, it has to be 3 here, but this can't be 3 because of 3 in the column. So this must be 5 and 4 adding up to 9, which makes that 7. 3 eliminates 3 in the rest of this box here. 1 eliminates 1 here, so it's 2, which makes that 1. Okay. Remaining digits of row 7. We have 2, 4, and 6. Okay, this can't be 4 or 6 because of 4 or 6 in the column. So that's 2. That eliminates 2 in the rest of the row. So this is 4 or 6 there. Remaining digits of column 3. We have 2, 3, and 7. And 2 cannot be here, so this is 3 or 7. 2 can't be here because of the 2-4 pair in the row, so this is 307, which means this has to be a 2 remaining in column 3. Okay. Can this ever be 7 here? If this is 8 and this is 1, but that doesn't work because we have a 1 already in that row. So this cannot be 7. It's 3, which makes this 7 there. 3 and 3 add up to 6, but we'd have a repeat in the box, so that's not allowed. 3 and 4 works there to add up to 7, and 3 and 5 does not work because of 5 already in the column to add up to 8. So this must be 3 and 4 adding up to 7 there. 3 eliminates 3 here, so it's 5 and 3. 1, 5, and 2 add up to 8, and 3 and 4 add up to 7 here, so 4 makes this a 2 there. 2 and 5 add up to 7, but 2 and 7 would have to add up to 9, but that's not possible because of 7 in the box. So this must be 2 and 5 adding up to 7 there. Okay, remaining digits in row 3. We have 8 and 3. This can't be 8 because of 8 in the column, so that's 3, which makes this 8. Remaining digits of column 7. We have 5, 3, 5, and 9. This can't be 3 or 5 because of 3 or 5 in the box. So this becomes 9. This can't be 5 because of 5 in the row, so that's 3, which makes this 5. 3 and 4 add up to 7, but that's not possible because of 7 in the box. 3 and 6 then must add up to 9. So this must be 6, so that must be 4. 7 eliminates 7 here, so it's 9. 3 and 6 add up to 9, so this can't be 9. And the rest is just normal Sudoku. We have 8 2s. We know where the last 2 has to be. It has to be there. 3s. We have 8 3s. We know where the last 3 has to be. It has to be there. That's 3 in the corner. We celebrate because we're close to solving this. 4. We have 8 4s. We know where the last 4 has to be. It has to be there. 5. We have 8 5s. We know where the last 5 has to be. It has to be there. 6s. We do not have enough information. 7s. In row 2, 7 cannot be here because of 7's in the box. 7 can't be here because 7 in the column, so 7 has to be there. That gives us 8 7s. We know where the last 7 has to be. It's there. 8s. In column 8, 8 can't be here because of 8 in the boxes, so 8 has to be there, which makes this 6, which makes that 8. 6 eliminates 6 here, so that's 8 and 6. That gives us a lot of 8s. That gives us 8 8, so we know where the last 8 has to be. It has to be there. 9s. In column 2, 9 cannot be here because of 9 in the row, and can't be here because of 9's in the boxes, so 9 has to be there. That gives us 8 9, so we know where the last 9 has to be. It's there. 1. In row 1, well, specifically in this upper left-hand box, where is 1? It has to be there. That means in row 2, it has to be there. In column 1, it has to be there. We have 8 1s now. We know where the last one has to be. It's there. We have 2, 3 already done. 4's done. 5's done. 6 was the next one. So this one last is 6, and that must be 6 over there. And that's the solution. Yeah, fairly straightforward. Very cool though. I like the patterns, which is why I chose this puzzle actually. I just like the pinwheeling around. And yeah, it's pretty straightforward in the solve. Nothing too hard. Just basic Kropke, Renband, and just adding arithmetic, adding up. And arrows up. Yeah, well, arrows is the adding up part, right? So anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.